Hello, so in this video we will talk about phrase structure grammars. Basically, uh, this topic comes under generating languages and grammars. Okay, so let's start with the definitions as usual. So, what is a formal language? A formal language is specified by a well-defined set of rules of syntax. Okay, and syntax is basically supported by grammar, and grammar is what? Grammar does two things. It helps in specifying the validity of some sentences, and it also helps in generating valid sentences. Okay, so helps in specifying which sentences are valid in a formal language, and helps in generating valid sentences in a formal language. Okay, so what is a vocabulary? Vocabulary is a finite set of elements, and elements are also known as symbols. And a word or sentence over V, so I should call it a V. V is a string of finite set length of elements in V. So for example, if V is equal to 0 and 1, so a word may be 0, 0, 1, 0, 1. Okay, so this is a finite length of elements in V. Okay, and string containing no elements is called the empty string and usually denoted by lambda. And set of all words over V is denoted by V star, and a language is defined which is defined by a subset of the set of all the words defined the set of all the words over V. Okay, in other words, language is just a subset of V, a V star. Okay, now we talk about special kind of grammar, which is a phrase structure grammar. Okay, so a phrase structure grammar has four parts. It is denoted by G, and it has a set V, a set T, a symbol S, and some rules P. Okay, so it has a vocabulary V. Okay, vocabulary we have already defined here. And T is a subset of V containing of terminal elements. Terminal elements means which cannot be replaced by other symbols. Okay, excuse me. And then we have S, which is a start symbol from V. So it must have a start symbol. And then we have a finite set of productions P, and productions are what? Production are nothing but rules which specify the replacement of one string in V star by another. So for example, if Z0 is can be replaced by Z1, we write that Z0 right arrow and Z1. Okay, and the subset, uh, we have defined the terminal elements, and the other elements in V which are not terminal elements, they are called non-terminal elements by obvious reasons, for obvious reasons. Okay, and the other rule for phrase structure grammar is that every production P must contain at least one non-terminal element on its left. So for example, this is the left side and this is the right side. That's what on its left means. About derivation. Okay, now we again consider the same phrase structure grammar VTSP, and let's say that Z0 can be replaced by Z1, and it's in the production of G. Then if W0 is a concatenation of symbol L, symbol Z0 and symbol R, and W1 is a concatenation of symbol L, symbol Z1 and symbol R, then we say that W1 is directly derivable from W0, and we write W0 is derivable from W1 is derivable from W0. So note that because Z0 can be replaced by Z1, so we can just replace this symbol by this symbol in the whole concatenated string. And change of derivations, so we can say W0 can be replaced by W1, or W1 is derivable from W0, W2 is derivable from W1, and so on up to Wn derivable from Wn minus 1. Then we say that Wn is just derivable from W0, and we write it like this. And the sequence of steps used to obtain Wn from W0 is called derivation. Okay, so language is, again we start with phrase structure grammar VTSP. So language generated by G, which is denoted by LG, is the set of all string of terminals that are derivable from S. Okay, so in other words, in mathematical language, all elements of T star is what? All the finite concatenation or set of words that can be generated from T, that is denoted by T star. So all the elements which are in T star, such that we can go to those elements from the starting symbol. So that is the language of G. Okay, now this is just talking, and this is a definition. It's important to define these definitions because we are going to use them in many of the problems. Okay, now we see the first part. Remember what we said, there are two purposes of a grammar. It checks the validity and it generates valid sentences. So we are in this work we are trying to check for validity of a grammar. Okay, so the question comes like this. We have a phase structure grammar VTSP with V is consisting of these four elements. Terminal elements are only 0 and 1, and productions are these four. Okay, now the first question is, does 111000 belong to LG or not? So let's see whether we can start with S and reach 111000 or not. So let's start with S. So S can be written as, S can be replaced by 1S. Now note that S is what? S is a non-terminal element or a terminal element? S is a non-terminal element. Okay, so it's on the left side. So the rules of grammar are actually maintained. Okay. So 1S. So can we replace this S, this second S by 1S? So we can say 1S. Then we can say 1S. Okay, so replacing this S by this 1S. So now I can replace this S by 00A. So I can say 11100A. Now it still has a non-terminal element, so I can still move on. Or A is replaced by 0. So I can just say A is replaced by 0. So 111000. Now I cannot move forward because all of them are terminal elements here. So this means this is in a language of my G. So this means the answer of this question is yes. Okay. Now does 111001 belong to LG? So without going there, when do we stop? So we should always stop at 0 because this is the only terminal element which does not have any concatenation of a non-terminal element. Note that this is the right hand side 1S. So 1S we have to move. This cannot be in the language because S is not in T. Then 00A cannot be in the language because A is not in T. And 0A, this whole string cannot be in the language. So it cannot be because it is not in T. A is not in T. But 0 is in T. So this means we have to stop at 0, which means that LG elements must end at 0. So this means that this guy cannot be in the language. Okay. Now we are trying to generate. Now this is the checking for validity and this is for generating. Okay. Now let's see what is LG. Okay. Now for LG, so for S, remember that we can go on and on. We can say 1S, we can say 11S, we can say 111S, we can say many ones S and so on. So in other words, we can write 1NS. Now this is not 1 to the n. This is showing that this is n ones and then S. Okay. And then what? Now another option is that I can say S00A. Then I can say 0000A. Then I can say 0000A and so on. So I can say that it has 0 and 2n A. Why can I say that? because I have two zeros concatenated at every step. Okay, and then I can also say s to the 0 uh, 0a, and I can say, because a can be terminated at 0, so 0 0 0. Okay, and also I can say s 0 0 a 0 0 0 0 a, and then I can say 0 0 0 0 0. So this means that this story here, means that I have always 2n plus 1 zeros. That's it. So I can at least have 3 zeros. 0a story. So let me write it here. S is 0a and a is 0. So I can say s 0a 0 0a 0 0 0a, and so on. I can say 0 to the n a. Okay, now note that this and this can be combined. So if I want 3 zeros, I can say 0 0 a and then a ends ending up at 0. And then if I want 3 zeros, I can also say 0a 0 0 a and then a ending up at 0. So this one I can say 0, and then if I want to terminate it, I can just say 2n plus 1 zeros. Here also, if I want to terminate it, I can say 2n plus 1 zeros. Now note that this is combined, so all what this does is that I can have any number of zeros. Okay, so the language generated is something like this. I can have all zeros and zeros. I can have 1 and then some zeros. So I can say k ones and n zeros. Okay, so this is the all language I have. I can have a string of all zeros, or I can have a string of some ones and some zeros. But I cannot have a string of some zeros and then ones, or I cannot have a string of some one then zeros then ones and zeros. It has to start either with 1 end up at 0, or it has to start either at 0 and ending up at 0. So this is the language generated by this grammar here. Okay, with a set of productions. Okay, so again, what we do is, all we do is we go to the definition and see systematically how can we build all the derivable terminating elements, a string of terminating elements. Okay, remember this is still, they all have terminating elements, correct? Because terminating elements are zeros and ones. So this is a subset of T star and this is a subset of T star, all of these parts. Okay, so this is it about an introduction of phrase structure grammar, and how we can check the validity of uh, check the validity of some words or sentences over the language, or we can generate some words or sentences over a language. So this is it about this video, in which we can check the validity of some sentences or words, or we can also generate valid sentences in a language. Okay, so thanks for watching and hope you liked the video.